Hello everyone, welcome to the YouTube channel of Lightway Research and Technology Center. In this video, I will show you how to interpret quantile regression results. In one of our previous videos, I explained what quantile regression is and why do we need to use a quantile regression model. But briefly, I want to state that quantile regression model does not rely on the assumption of OLS. So in a situation whereby one or two assumptions of the classical linear regression model fails, you can make use of quantile regression model or quantile regression method for your data analysis. Please, if you don't know how to estimate a quantile regression model, kindly check our previous video on quantile regression analysis. But in this particular video, I will show you how to interpret the results. Of course, I will estimate our quantile regression model before proceeding to the interpretation of the results. But here are the things I want you to take notes. In any quantile regression model, you will always have a dependent and independent variable. Your independent variable may be one or more than one, but your dependent variable will always be one. And the relationship between your dependent and independent variable can either be positive or negative, significant or insignificant. But one important thing you need to take note is that when you are interpreting your results, you must state the quantile or the percentile at which that particular results occur. For instance, if you estimate a model at 10, 20, 30, 40, 50, up to 90 or 95 quantiles, and you notice that in the first two quantiles, there is a positive relationship between the independent variable and the dependent variable, you must state it clearly in your explanation that in the first two quantiles, that is 10 and 20, x has a positive and significant relationship or positive and significant impact on y. So now let us assume that we have our quantile regression results for 25 and 50th quantiles, and here our x is the independent variable while our y is a dependent variable. So when you have results for your quantile regression, to interpret it, you simply say that the effect of x, which is independent variable, on y is positive. That is, if the sign is positive. But if it is negative, you state it that is negative. And also the next thing is whether it is statistically significant or not. So let us assume you are using the conventional level, which is 5%. So if the probability value is less than 5%, that means it is positive and statistically significant. It is positive and statistically significant at 25th and 50th quantiles at 5%. Let us assume we are using 5%, which is the conventional level. This 5% is 5% level. But in a situation whereby the 25th quantile is significant at 5% and 50th quantile is significant at 10%, then you say that the effect of x on y is positive and significant at the 25th and 50th quantiles at 50 and 10% respectively. So what does this mean? It then means that y increases when x is below the median or at the median. You know, the median for quantile regression is 50 quantile. That's 0.5 quantile or 50 percentile. So now what the result means is that when the x is below the median, or when it is at the median, when it is below the median, and when it is at the median, an increase in s leads to what? Increase in y. So that is how to interpret that particular result. So what we are trying to say is that s significantly affects y as the 25th and 50th quantile. But if the relationship is not significant at 1%, 5%, or 10%, then you say that though it is positive, it is not what? Statistically significant at 25th and 50th quantile, which is at 5% or 10% level. You can also say that B1 is the estimated rate, that is this B1 stands for the coefficient of x. This is beta 1. It stands for the coefficient of what? Of x. Let us assume the coefficient of x is B1. So you can say that B1 is the estimated rate of change in the 25th quantile in a dependent variable y for a 1% change in the independent variable x. So you can also interpret your results this way. But what is very, very important is that you must specify the quantile of that particular result. So now let me take you through how to do this in EViews. Okay, this is the model we estimated in our last video, and here the dependent variable is maternal mortality rates. We have two independent variables. The first one is government health expenditure and the second is urbanization. So now to estimate this model, you select the dependent variable first, which is MMR, maternal mortality rate. Then you now select the independent variables, government expenditure and urbanization. So you just right click, then you open as equation. Here you select quantile regression, use the median. This is the median, 0.5, so we retain it. Then you click OK. In case you don't know how to do this, please check our previous video. The next thing now, this result is only for the median, which is 0.5 quantile. But to obtain a result for like 10 quantiles, then you need to go to view, select quantile process, then process coefficient. Here we are going to retain it, we want for 10 quantiles, then you click OK. So this is our results for quantile regression. This is our results. So what you need to do now is to interpret your results, and that is very simple and straightforward. You just need to master the art. Once you know how to interpret it, you will not have any issue. So the first thing is to look at the results very well. You can see the first column we have quantile, the second column we have coefficients, third is standard error, and the next is t-statistics, and the last is probability value. So what is the columns that are very important here are 1, the quantile coefficient, 2, then the probability value. So we can copy these results now and take it to my notepad here. I've already done the interpretation, but I need to show you how I interpreted it so that you can understand the process. Also, you can get your graph. In fact, I will advise you to always present the graph as well. So if you want to get the graph of these estimates, you just need to go to field, quantile regression, quantile process coefficients. Then here, instead of table, you select graph. The confidence interval, maintain this 95. Okay, so this is the graphical presentation of this particular results. This is the graphical presentation of the results. So what you just need to do is to present the graph as figure 1, then the table as the results in the table as table 1. So in this particular case, I'm assuming that we have the graph as well as the results. So this is the results. This is the quantile, this is the coefficients, this is the standard error, and this is t-statistics, while this is probability. So let me just adjust this so that it can fit. Let me use quant for quantile, then this for coefficients, then standard error, t-statistic, probability. I believe others are okay. Okay, now let us go through the results. If you look at it, we have 10 percentile, 20, 30, 40, 50, up to 90. If you want to estimate 95, you can just go back and instead of using 0.5, you just type 0.95 there. But we are okay with this, so let us just go through the quantile first. We have from 1 to the 9th quantile, and we have the coefficient. So now what you need to take note is this coefficient increase or decreasing? If you look at the first quantile, we have 0.464323, and the second quantile 0.439369. You can see it's decreased, then it's increased, decreased. So it is not stable, and that is what this particular blue represents. This coefficient is what this line represents. The red here and this, those two lines are they stand for the confidence interval. And the next thing you need to look at is the probability value. Don't forget that we have 3 levels of coefficient. The first one is 1%, the second one is 5%, and the third is 10%. So if you are using 10%, that means 1%, 5% are also okay. But if you are using 5%, that means 10% is not okay for you. But in this case, we are going to stick to the 3: 1%, 5%, and 10%. So looking at the results, you can see that all the quantile, the results of all the quantiles are significant. This is the highest, which is significant at 10%. But let's use 1%. Let's use 1%. So if you are using 1%, this particular one is not significant. If our significance level is 1%, then this 80th quantile is not what? Is not significant. So now, let us interpret this particular results. First thing you take a look is it positive or negative? It is positive. Is it significant or not? Yes, they are all significant except for this 80th quantile. What happened to this coefficient? Which one has the highest? Which quantile has the highest coefficient? The 30th quantile. Is it below the median or not? Yes, it is below the median. The median is this, which is this 655,399. But the one with the highest, the quantile with the highest coefficient is 0.3 quantile. So now, based on this thing that I have just said, we can proceed to our interpretation. First, you need to let the audience or your readers know that you make use of quantile regression, and how many quantiles do you estimate. So that's the first thing. Now look at this particular interpretation. We estimate the heterogeneous impacts of government expenditure and urbanization on maternal mortality rates with the quantile regression method. What methods do we use? Quantile regression, we have specified that. Of course, you can do this in your methodology. Once you indicate the method in your methodology, under discussion you don't need that. But here we don't have a methodology. That's why I decided to indicate the method of analysis. So the next sentence now says the result for the 10th, 20th, 30th, 40th, 50, 60, 70, 80, and 90th percentiles are presented in table 1. So let us assume this is our table 1. Are presented in table 1, and this is our what? Our figure 1. So this is our what? Figure 1. Don't forget, this particular result is the same as this. The only thing is that instead of the here we don't have the standard error, we don't have the t statistics, and we don't have the probability value. We have the quantile. You can see it here. This one gives up to the 10th quantile, but this one stops at 9, which is reasonable. Then we have the what? The coefficient. This is the coefficient. This is this blue line, and this is government expenditure. This is urbanization. This is government expenditure. This is what? Urbanization. Now, the result for the 10th to the 90th percentiles are presented in table 1 and presented in table 1 and figure 1 reveal that government expenditure and urbanization have asymmetric effects on maternal mortality rates. Their effects are not the same. That is asymmetric. They are different. You can see this one is 4.6, this one is 7. So they are not what? They are not the same, or we can say heterogeneous. So the effects, the magnitude are not the same. So that's why we say we indicate is there that it is what? It is asymmetric. You can use your own words, the one that is best for you. But what we are just trying to say is that the magnitude are not what? They are not the same. And if you look at these two, this one is positive, urbanization is what? Is negative. Now look at the third sentence. In row 1, this is our row 1. This is our row 2. Let me try to state that clearly. We have 3 rows here. Row 1, government expenditure. Row 2, urbanization. And row 3 is the constants. I believe that one is clear. Then we have column 1, 2, 3, 4, 5. So now let's go back up. In row 1 of the table, the impact of government health expenditure is positive and statistically significant for the 10th to the 60th percentile at 1%. You can see from 10, 0.10 to 60th is significant at what? At 1%. This is less than 1%. That's why we say it is significant at 1%. 70th and 90th percentile at what? At 5%. If you look at 70th, is what? This is greater than 1%, and 90th is greater than what? 1%. So these two quantiles, the result as significant at what? 5%. And 80th percentile at what? 10%. This 80th. So if we are using 1%, now that means this one and these last 3 are not significant. If our best level of significance is 5%, that means 80th percentile is what? Is not significant. But here we are using the 3. That's why I specifically drafted the interpretation like this. So you need to let your readers know that, okay, quantile 1 to 60th, the estimates of quantile 1 to the 60th quantile are significant as what? They are positive and significant as 1%. 70th and 90th are positive and significant at 5%, while 80th is what? Is significant at 10%. So once you state that, you are true. Now you need to look at the magnitudes. So that's why I move on and say specifically the research shows that government health expenditure has the largest, you can see this is the magnitude here is the biggest, is greater than other magnitudes. So that's why I say it has the largest impact on maternal mortality rate as the 30th percentile. And what does this mean? It then suggests that mortality rates increased more when government expenditure is below the median. You understand? Why do we say it's below the median? Because 0.5 is the what? Is the median, and 0.3 is less than 0.5. So maternal mortality rates will increase more when government expenditure is what? Is below the median. We are more concerned about the increase here because the results are what? They are all positive. Assuming one or two of the quantiles has negative impact on maternal mortality rates now, then we need to emphasize that. But all the results are what? Are positive. So we need to let policymakers to be aware that maternal mortality rates will increase more when when government expenditure is less than the median value. So once you have done that, then you are true. The next thing is to link your results to what other researchers have provided. Let us assume that Mr. A in maybe in South Africa or in UK has submitted the same results. Then you can make reference to that okay, these results align with the findings of Mr. A, Mr. B, and Mr. C. Then you need to let us know whether these results conform with the a priori expectation. Of course, this is not in line with the a priori expectation because what is expected is that government expenditure should have a negative, that is, it should lead to a reduction in the level of mortality rates. So you need to state all that, and if you are the first to obtain this particular results, then you need to tell us why. Why is this happening? Then when you are trying to tell us why, you should be able to write a story about certain issues in the country where this particular study is conducted. Then you use those issues to support your findings. So that is how to interpret the relationship, the positive relationship. Now let us look at the second independent variable, which is urban. Now look at it. Here too we have quantile from the 10th quantile to the 90th quantile, and all the results are what? Negative. In this case, the results are significant at 1% level, so we don't need to make reference to 5% and 10% again. So what you just need to let us know is that this has a negative impact on maternal mortality rates across the quantiles. So now let us look at it. Conversely, why do I use conversely? Is because this result is opposite of that of a government health expenditure. Conversely, the impact of urbanization on maternal mortality rate in row 2, this is our row 2, is heterogeneous, that is the magnitude. They are not the magnitudes, the coefficients are not the same, so that's why we say it's heterogeneous. And significance at 1%, this probability value tells us that the results are significant at 1% across all quantiles. So if you look at it, 10th to 90th quantile, the probability value is less than 1%. So that's why we say the impact is negative and significance as what? 1% across all the quantiles. Look at the next sentence. The research shows that urbanization reduces maternal mortality rates at all quantiles because the coefficients are what? They are negative. But its impact differs across the 9 quantiles. That's why we say they are heterogeneous. This 16, let us look at the absolute value now. 16 is greater than 15, is greater than 13, is greater than 14. 14 is greater than 12. You understand? 15 is greater than 13. So that's why we say the effect differs, or the impact differs across the what? The quantiles. The largest reduction in maternal mortality rates occurs at what? 30th quantile. The same. If you look at it now, you will see that the lowest value here is minus 16.98053. This is the lowest. If you look at the absolute value, let us take a look at the absolute value. You will notice that this is what is the highest. So when you are looking at the real value now, it is the lowest. So that's why we say the largest reduction in, or you can say the biggest, the whatever, just use your own words that fits the sentence. The largest reduction in maternal mortality rates occurs at the 30th quantile, suggesting that mortality declines significantly because this is less than 5%, with increased urbanization below the median level. You can see 30th quantile is below 50th quantile. So this is how to interpret your results. What next now is to compare your results with the literature. Is this result aligned with the findings of other scholars? If yes, you let us know. Is it aligned with the theoretical prediction? If yes, you let us know. Then from there you tell us a brief story and you provide a recommendation. So with this, we have come to the end of the interpretation of quantile regression results. You don't need to interpret the constants. You don't need that. Please, if you are just coming across our channel for the first time, kindly subscribe to be part of this great community. Also, like our video, share with your friends, your colleagues, and every other one that you believe will be interested in our videos. And to our existing subscribers, we say thank you for what you have been doing for us. In our next video, I will show you how to perform the post-estimation test for quantile regression and how to interpret the results. Thank you.